You are the pioneers, with your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process fellows.
Yeah, welcome to our today's webinar about artificial intelligence and automotive systems, aligning with ISO PAS 8800, which is actually presented by my colleague Sebastian Keller and moderated by me. My name is Jürgen Schmid. Before we start with the presentation done by my colleague Sebastian, of course, we are doing a very quick introduction of our company. And as you can see, our portfolio is actually dealing mainly with the topic process improvement, which is here highlighted in the middle of the slide. Therefore, you find some topics like process, all kind of SPICE models, or in general, the organizational change in companies. In addition of this kind of generic process improvement topics, we are dealing as well with project management and introducing HR methodologies. And project management and HR methodologies are often supported by application lifecycle management tools. So, for example, we are doing as well consulting and coaching about introducing tools like Jira, Polarian, or other similar application lifecycle management tools. In general, our focus is on systems engineering, and this does not only cover topics like Automotive SPICE, but as well topics like cybersecurity or functional safety. In these topics, typically we provide several kind of services. So first of all, we are doing, of course, trainings and consulting. In addition, we are supporting as well our customers with detailed coaching within the project teams. And of course, if it's about SPICE and process improvement, often the topic of informal assessments or formal assessments is coming up, and both is supported by us as well. On one hand side, maybe in the beginning of process improvement, right? Then it's often a gap analysis, or towards the end of process improvement, where we are supporting with an official assessment. Yeah, something which was actually just recently published. So recently means here in July this year. Maybe you already heard about our new website, SPICE for Cars. Actually, SPICE for Cars is a kind of model browser. On the one hand side, we integrated all the relevant SPICE models for automotive industry. So this means actually automotive SPICE, but as well mechanical SPICE, automotive SPICE for cybersecurity, and as well this pretty new assessment model, which is called potential analysis. So this is on the one hand side the content, but on the other side, we really mapped as well so-called knowledge nuggets. Knowledge nuggets are some kind of additional knowledge or information which supports you to better understand the interpretation of automotive SPICE and gives you some ideas about the interpretation and implementation about those base practice and generic practice, for example. Just try it out. It's for free. And just visit us at spiceforecast.com. I want to explain that we are doing as well trainings and consulting. So here we are showing the next few upcoming trainings. As you can see, we have as well some guaranteed trainings right in the next couple of weeks. Maybe let me especially highlight the second one on the left side, which is a training which is done through a cooperation partner in Hungary and as well in Hungarian language. So this is pretty new. Most of the other ones is often done in English language. Maybe just a few comments about the webinar and how to deal with maybe upcoming questions. You should see in your Microsoft Teams, either in German language or maybe in English language, depends on your user interface, a button which is called question and answers, Q&A, or maybe F&A. And we will use this section for collecting the questions. So don't hesitate to write down your questions here in this section. And after the presentation, we will go through all of them. The webinar is, of course, recorded like it's typically done, and you will find the presentation in a couple of days on our website, and as well the recording will be uploaded to our YouTube channel. I guess this will be done maybe by end of this week. So just give us maybe 2 or 3 days, and then you can watch it, or you can distribute it as well to your colleagues. Yeah, now I already want to hand over to Sebastian. So maybe a very brief introduction of Sebastian. So he's on the one hand side Automotive SPICE competent assessor and ISTQB certified tester. Actually, I think he started his career in the topic of verification, validation, before he then moved over as well into the topic of functional safety, Automotive SPICE in general, and this, of course, includes as well several other topics. So the stage is yours, Sebastian. Maybe you can share your screen and just continue.
Yeah, thank you, Jürgen, for the introduction, and a warm welcome from my side too. Just give me a second to share my screen. Okay, now it should be visible to all of you. And I think we can start with the webinar itself. As Jürgen already mentioned, it's about AI in automotive systems, and we will see what is relevant here, especially for safety, because the topic today is the ISO PAS 8800, and that's about today. So the question would be, what makes our vehicle safe? So that's the basic question. And for the introduction, of course, we have some topics that are safety relevant. So in general, of course, we have some laws that require safety. So no vehicle can go on the road without proving that it's safe to the regulations and to the law. Then, of course, I think all of you know the ISO 26262. But if we're talking about modern times, if you're talking about artificial intelligence, the question would be, is the ISO 26262 enough? In addition to this, we can say, no, it's not enough. We got the ISO 21434, for example, the cybersecurity. And again, we could do the question, is it enough to have the ISO 26262, so functional safety in general, and the cybersecurity? And of course, we have, in addition to this, our processes. We all know Automotive SPICE, for example, is process framework. And the question again is it enough to have this? So we have laws that require safety. We have a safety norm or safety standard, the ISO 26262. We have processes, a good process landscape according to Automotive SPICE. We have maybe cybersecurity already implemented. And then the question would be, what else? And there we go to a kind of, let's say, landscape. Where are those topics located? And if we go to the landscape and see, okay, we have our classical systems, deterministic systems, for example. We have AI systems. That's one of the parts. And in the other direction, we got, for example, the technical or normative topics. And of course, we got laws and regulations. And if we go to the ISO 26262, for example, then we see it's a technical description, how to develop safe. And that's for the classical systems we know. We know since years for software, for electronic systems, for, let's say it, or let's call it deterministic systems. On the other side, we got the law, the regulations, and here we got several different ECE regulations, for example, that say what to do to have a safe vehicle, for example. Not the technical side, but the regulations side. And it demands, for example, safety by design. The design, how to develop safe, is described, for example, in the ISO 26262. On the regulations side, we have, in addition to ECE regulations, for example, some topics on the level of AI systems. So in Europe, we have the EU AI Act, for example, in the European Union, that shows and that tells us what we have to consider when we're using AI. In this case, not especially for the road vehicle, for example, we are developing, or the component, but in general, what do we have to consider if we're using AI in our company, for example, in our organization? In addition to those topics, we have additional topics like, for example, cybersecurity. I already mentioned cybersecurity is important, but it's not a direct part of the functional safety. But we will see this later on at the edge. An additional point we've seen in the slide before is we have Automotive SPICE, for example, kind of, let's say, process frameworks that we are using for the development to ensure a safe development, to develop, let's say, state-of-the-art processes. And if you're talking about AI in this case, then especially we have the machine learning extension, for example, that describes processes if you want to have AI implemented into your vehicle. And now we can see there is a gap here on the top. So what's about this gap? And here we come to the ISO PAS 8800. That is the, let's say, normative side of the AI systems, kind of related to the ISO 26262. But why do we need this ISO PAS 8800? So in general, we have limitations of the ISO 26262. So the ISO 26262 assumes a deterministic behavior. So if we have input, we will always have the same output in our system. So we expect that, but an AI system won't give us the same output, for example. It's not deterministic. It's a learning system, for example. Then in the ISO 26262, we have no concepts, no description about the concept of training data, for example. So data in general in the 26262 is not very relevant. And of course, if we're talking about AI and training, we need data, we need sufficient amounts of data. And of course, we need to trust the data. So we're talking about a controlled life cycle, for example, for the data we have. Then the ISO 26262 relies on, let's say, more or less specification-based verification. So the verification approaches we have in the ISO 26262 are the classical ones. We have a specification, we have implementation, and later on we have a test or a verification for this. But in case of the AI, of artificial intelligence, maybe it's not that easy to test just the specifications, because, and that will come later on, we don't know if the output is always the same. We have some other approaches that have to be used, like trust of the model, for example. And of course, the ISO 26262 does not describe all of the roles that we need if we apply AI. So we have to define new roles, new metrics, for example, that are relevant for the AI. Going a little bit deeper in those topics. So what is the purpose and scope of the ISO PAS 8800? So in general, we can say it provides a guidance for the use of AI in safety-relevant automotive systems. And as we've heard in the slide before, it addresses non-deterministic AI, systems. So we've heard about machine learning, for example. That's one of the topics. And what's very relevant later on, it does not replace existing standards. It complements them. So there will be some systems later on that you will see in the development, for example, that consists of components or items that are AI and that are non-AI. So you will always need the ISO 26262 for the non-AI components and not only the ISO PAS 8800. So the ISO PAS 8800 is only for AI components or AI systems, not for the classical ones. There, the ISO 26262 will be still relevant. Why does this matter? Because the AI challenges the assumption of traditional safety standards. So the traditional safety is more evidence-based, more verification-based, and that's not always possible for the AI. Then, of course, I've told you before, it's very, very relevant that we have a high data quality. Data is a very important point of the AI. Then we have a kind of model behavior. We have relevance on runtime environments. And as we've heard before, it's about new roles, then governance, for example, of data again. And of course, the risk management concepts can be some kind of different than in the ISO 26262. Yeah, and as I described already, it forms the missing link between the functional safety and kind of AI governance. But why is AI so different? We've already heard there are some topics, and we will go into those topics later on. The topic number one, or one of the main topics, is the non-determinism. The non-determinism, will challenge our traditional safety concepts. I already said to you. Then the data. Then of course learning instead of coding. That's one of the main topics that is different in AI than in classical software development. We don't have the code, the handwritten or the model-based code. We have a model that is trained with data and that is doing something we do maybe not know what exactly inside of the system. So it's kind of black box, but we will hear the word of black box or the term of black box very often in this webinar. And of course, as I mentioned already, we need new verification approaches. But let's go into some of those points. So the first one would be, what's the difference between classical software and AI systems? So in general, as I mentioned, we have the behavior of the classical software defined by the code. The code which is written, which every software developer can go through and can see what it is doing, what it is written there. And therefore we have a fully deterministic logic in the code. So we can give an input. Let's get to the last point here. We can have an input here, and of course we have a defined output for a defined input. And that's a point we can verify easily. So input and expected result, for example. On the AI-based side, we have the behavior, as I mentioned, learned from the data. So we don't know what the AI exactly is doing. So we have a basis and we have expectation, but how the result gets from our data, we don't know this. So it's non-deterministic. Then, of course, if we go in the direction of requirements, for example, it's hard to verify directly all of the requirements, or if we go through the left side of the V-model, then we can't verify all of the defined points there. So that's a problem. So we have to evaluate our trust in the system by other metrics. So for example, confidence scores, how exact is the output, how confident is it? And of course, I mentioned already, we will often hear the word black box, because in the classical software, we know what our code is doing. We know the decisions. If we have a if-else decision, we know what it will do. But on the AI side, it's kind of black box. We don't know what the system exactly is doing. Yeah, you've heard some of the words already. So the same input may lead to different outputs. That's one of the points here. The behavior is influenced, of course, by training data, model state, randomness. That's one of the other points here. So even with the same input, we may have different outputs. So that's kind of, it's not random, but it's strongly influenced by the training data and the model. And of course, it's hard to explain later on. So how is it possible for us to explain what did or why did an AI choose the result it gives to us? So an example that is always told is about wolves and dogs. So a model was trained to separate wolves from dogs, and it was very good. But at the end, the question was, why did it decide that in one image there is a wolf and in other images there's a dog? It was not because of the animal in the image. It was because of the environment where it was. Wolves were mostly in snow. So the model decided if there is snow, then it should be a wolf. So the decision was the correct one, but it was not possible to have the correct basis of the decision. Yeah, and if we don't know how are decisions made, how can we go back? Of course, it's hard to do a traceability and a justification for the results later on. And that's kind of what I told you. Yeah, that's kind of black box behavior. So we have to get there that we have a kind of trust by new methods that are applied later on. Then another topic we have is the topic of data. The data is there, in this case, a relevant part of the product. So in general, in a classical software system, we don't have data as part of the product. That's here more relevant in the AI because the data is the basis for the behavior. The training data is the basis for the behavior of our product. So that's a very relevant part here. And if you do, or if you fit in a poor data, then of course your safety mechanisms or your outputs will be poor too. Even if you have a perfect model, but if the model is trained with the wrong data or poor data, that's a problem. The same is for the bias. Data that is not representative, for example, can lead to wrong results. So, for example, if you only train good weather conditions, what will the system do if there's fog, for example? So that can be a problem too. Then the drift, the data can change in time. Again, if we take the weather, for example, then we have the possibility that we say, okay, the model maybe was trained with data from the summer. Now we got winter. So if we get a lane detection that doesn't know snow on the streets, maybe we don't know what it will do later on. So that can be a problem too. It's kind of nearly the same point as on the top, garbage in, garbage out. If you feed it with bad data, you won't have a good system, or you will have some risks later on in your deployed system. And of course, what do we have to do then? We need some kind of governance, traceability, and monitoring, not only for the models itself or for the system itself, also for the data. Then another point we've heard is about the verification and validation. In classical systems, as the topic says, coverage was one of the main topics. But in this case, we have the topic, we don't know if the coverage is enough. Is it enough or what can we do there? And the problem is that the behavior of the AI is not, or normally not fully specified because it's kind of black box. So the question is, how can we verify a not fully specified system later on? And that's kind of, if we don't have a fixed output for each input, like I said before, then how can we know what is correct? So traditional approaches, like for software, the coverage matrix, for example, are hard to apply here. And I don't say absolutely doesn't, because there are possibilities, but it's not easy to apply such metrics here. So we need some more information for verification or validation of this software or of the system later on. As written here, some kind of, let's say, statistical validation. That's possible to do here. And of course, it's not about just testing the behavior in this topic of AI. We have, in addition, the topics of model behavior, for example, data quality. So we have to have an evidence, for example, that our data we have trained is good enough. That should be verified too. And that the training process was correct, for example. Yeah, then we will shift, as I said at the beginning, we will shift from did we test enough? Is every requirement covered, for example, to do we understand what it does? So like I've told you with the dogs and the wolves, do we understand why the decision is correct? Even if it's correct, maybe the model does in the background something totally different. And in later situations, it will do some failures. So for safety, I think that's not acceptable. And one last topic for the introduction. What about after SOP? So after deploying it in the vehicle, in the road vehicle, here we have the topic that it's possible that the context changes. So it may be some other context later on than in the training sessions. Therefore, we need some kind of monitoring. So for the performance of the system in the real world, let's say, then of course data drift. I already said there's possibility that the environment will change, for example. Unexpected behaviors, and some of you will say, oh, we already have to monitor some kind of safety issues in the real world now, but this will get more relevant for AI later on. What's important here is that we prevent from runtime learning. So if we have runtime learning, so the vehicle learns in the road vehicle maybe from the human driver, that should be prevented, because it could learn some of the failures that other drivers do. So myself, for example, maybe sometimes I don't totally stop at a stop sign, for example, and an AI could interpret this at, oh, it's okay to drive over the sign. But that should be prevented, and that should be done by feedback loops, where you do retraining in a controlled environment and then update. And therefore, we need, of course, update strategies with a revalidation, rollback traceability, and so on. And that's the interface now to the cybersecurity, because if we have to have some possibilities to update our system, our software, whatever, then of course we have to implement safety mechanisms on the one side and cybersecurity on the other side, because that or poor implemented cybersecurity, of course, can lead to safety issues later on, if it's possible, for example, for a hacker to deactivate safety mechanisms because the security is not implemented proper. Yeah, so the PAS 8800 stresses the need for post-deployment and lifecycle management, and that's one of the topics that we will see later on too. We need, of course, a role who will do this after the SOP, because the development organization normally will hand over the project to some kind of series, but not. But the project will be closed then. Yeah, but let's get to the ISO PAS 8800 itself. So just a few words to the norm. It was published in 2024 in December, so it's a really new one, and we can see it's safety relevant. It's really related to the ISO 26262 because it's the same working group that developed it than the 26262. Focus safety-related use of AI, as we've already heard. Then we got the machine learning functions for perception, decision and control. And as we've already heard, it addresses the limitations of the ISO 26262 and SOTIF. We won't go into detail, or we won't go into SOTIF here, because for our 45 or 60 minutes webinar, it would be too much. We will go on with the ISO 26262 here. Then it covers the entire life cycle. We will see later on, from concept to post-deployment updates, and it builds. It is built toward future standardization. It's currently a PAS specification, a publicly accessible specification, and maybe later on it will be part of an ISO, or it will be a full ISO later on, maybe. So in general, if we go into the ISO PAS 8800, we will have some key terms here, some words that we have to know, and it's not everything that is in the norm. It wouldn't be possible to do this in this time today, but we will see some of the definitions here. So, for example, the AI use case, that's kind of pendant to the use case from the ISO 26262, but in this case it's specific for the safety relevant application of AI, not for the system, it's for the AI, and of course that's a relevant point. Nearly the same is for AI item, for example. So we know in the ISO 26262 the item definition, and in this case the item would be the system, subsystem, element, whatever that is AI relevant. So where our AI functions are in the site. Then we have the kind of trustworthy AI function. So of course we have an AI function or an AI item maybe, and if we demonstrate that it's safe, however, for through an assurance argumentation and so on, then we can talk about a trustworthy AI function. Then of course we have the kind of safety goal. So as you know, for the ISO 26262, we have safety goals, and in this case, of course, we have an AI safety goal, and it's nearly the same as on the other topics of the 26262, but related to the AI. So it's not a general safety goal, but in this case, we can say, for example, AI safety violations that come from AI behavior. So in this case, we have, for example, failure to handle unknown inputs that is possible, that can lead to a safety goal. Then, of course, we have a topic that will come up later on too, the topic of a data strategy. So if we are handling data, lots of data, different data, and data lifecycle and so on, it is useful, of course, to have a data strategy. And if we're talking about data, I think we will see this later on too. Then we can also go into the Automotive SPICE for the new processes that are for machine learning, but we will see this later on. And for example, we can have kind of confidence measures. So I've told you about we have to have new verification measures, new metrics, for example, and confidence measure could be one of those that says us how is our confidence in the system, for example. So just some of the key terms, and I told you we will see so kind of short life cycle. So the life cycle in general isn't such different to what we know from other systems. Of course, we have some differences. We have safety goals, of course, that are for both of the systems. For AI, of course, there is the topic of an AI model. We have data and training. those are new or different from the ISO 26262 later on. Then we have evaluation and the monitoring. Those are kind of similar, but or necessary in both of the sides of the world, but not the same, let's say this way. So just that you know where to find the information about which part of the life cycle in clause 9 of the ISO BIS 8800. It's about identification of safety relevant AI use cases, derivation of AI safety goals from system context and potential hazards. So here we are doing what we know from the ISO 26262 as HARA, for example. Then if we go to the AI model, then of course we have to deploy a model. We have to choose a model that we will use later on. And this is, for example, an architectural decision. Which model is used in our AI system? Then, of course, which configuration will we do? Then management and versioning of those is described. So here we're on the, let's say, left side of the V model of the system development. And if we go one step further, then we see in the clause 11 the data and training then later on. So as I told you, we have a model, and the best model is nothing without a good data and a good training. After this, we have, of course, the evaluation. Evaluation is clause 12 and 13. So it's about verification, validation, that the training was correct, that this model is deployed correct. And here we can define the confidence matrix we've heard before. So do we trust our model? Do we trust what we've trained? How good is our model trained? How good does it fit to the needs, and so on? And in the last section then, clause 14, for example, or Annex B of the ISO, we can see then the monitoring after SOP with topics like model drift detection and update strategies that are part of this. As I told you, we have the problem that we have some additional roles, but in addition to this, of course, we have some roles that are already present. So what roles are already in the ISO 26262 necessary? I don't go through all of the roles, so please don't judge me if there's, for example, no quality manager or quality assurance. But here are the relevant roles that may have change or may have an influence on the AI. Established roles, for example, are the safety manager. So safety manager, of course, is a role that was necessary in the ISO 26262. But of course, if you have AI components, AI systems, then the safety manager has to align with the AI safety manager. We will see in this one on the next slide later on. Then, of course, we have the classical roles like a project lead. Project lead is still relevant, but of course, he has to consider that there are more activities, more roles in his project, other AI-specific topics that are part of his project. So project lead has to do different planning and has to consider the AI topics too. Then architect and developer, of course, they don't have only the to have the knowledge about the development of code, but they in this case have to have more knowledge. The role is expanded to how to implement, how to cover ML models, data, dependencies, and so on. So this role is still necessary, but is extended, of course. And if we go to through the development, of course, it's the same for a tester. Testers are still there. Tester will still have to do their test, their verification. But of course, they have new challenges. It's not possible to say, okay, input, yes, no, binary, black and white. In this case, maybe we have kind of gray with the need of explainability. why is the result with a confidence score of 95% okay for a safety relevant system, for example. So if it's not possible to reach 100% with the decisions of the AI. So there are more or new challenges for the testers, but the role still exists and already existed, of course, in the 26262. There are some additional roles that are necessary. For example, as I already told you in the beginning or on the last slide, the AI safety manager, for example. The AI safety manager owns the AI safety planning and lifecycle, of course. And why do I mention him here? I think in the most projects or most organizations, it will be the same person as the safety manager. So in general, I think it should be integrated in the role, but often the role description at this point does not include AI. In future, I think it should be the same role. Then we have something completely new, but I would say there are some parallels to other processes and other people there. So the data governance lead, let's say it this way, for example, we've already heard it is necessary to have good data, to have data, sufficient data, to have a high quality data. And of course, we need someone who is responsible in this case for the data now, because the data will be a very big part of the system and not just something maybe on the side of the development. So of course, we need someone who has the lead here with all of the data topics. And I would say it's kind of, let's say, in parallel to the configuration manager, who is a little bit responsible for the data of documents, for example, for the quality of documents, for example, and so on. So I would say that that's kind of in kind of this direction. And as you have heard, we have the topic of after SOP deployment. Then we need someone who is responsible for the operation that is in the series later on. So for post deployment, and there was already some needs in the ISO 26262, but it was not that present or that important. But in this case, we have topics like drift detection. So does something in the data, in the input data, in the environment change, for example? We have, if the need of updates there are post-deployment, is the behavior of the system correct, and so on. So we have to monitor the system later on, and therefore we have to have a role that is responsible for this. So just a few questions then about why traditional safety arguments don't work for AI. And we have some, let's say, arguments that say the ISO 26262 relies on deterministic behavior, for example. That's one of the points. And why does this not work for AI? Because we have non-deterministic systems. We have outcomes that can vary from one to the other cycle. And therefore, we have to have a new approach. And in the next slide later on, or in the next slides, we will see how does the ISO PAS 8800 treat those topics. But just at the beginning, the questions, why doesn't it work? Then the classical approach uses requirement-based traceability. So at this moment, we don't have a requirement-based traceability. We have training data. It's not line-by-line coding. Then we have, in the classical approach, a full explainability. We can explain what is done. We can explain which outcome will come through which input and so on. And that's here not the case. We have often black box systems. We don't know the internal logic of the neural network, for example. Then we assume a static system behavior, But as we've heard, it's possible that we have some kind of change over time, maybe because the input data in the environment changes. So it's not possible to say we have a static system behavior. Then we have a safety case via design verification and test coverage. We've already heard that's not possible because we don't know a 100% specification normally. So we need other forms of evidences later on. And if ISO 26262 or the classical approach focuses on fault-based safety, so for example, hardware or software malfunctions, and now we have more data-driven hazards, for example. The faults can be caused by bad or wrong data, for example. And now the question, how does the ISO PAS 8800 handle those topics? So for the first topic, the non-determinism, for example, it says in clause 13.4, we have to have an robustness and uncertainty analysis. So what can we do for robustness? For example, we can do some measures, whatever. We can do statistical validation. What could be such a robustness measure? For example, if you have an input, maybe put some noise on it or some fog noise on it to see if it gets the same result, even if we have a higher noise on the sensor, for example. So that could be possible for the non-determinism. Do we get good results later on? Then, of course, we have the behavior emerging from training data. And that's one of the topics we've already talked about. If we have data is very important part of the product, of course, we need, and that's clause 11 of the ISO, we need a dataset lifecycle management. We need to ensure that the data is treated as a safety relevant artifact. It's not just something at the edge of the development. It's one of the relevant points. And if it's one of the relevant points, then we have to treat it like one of those. Then, of course, what about the black box behavior? And therefore, we have the clause 8, or in this case, 8.4, where we have to do some kind of assurance argumentation. And we will see later on a short example how to set up such an argumentation, but very short example. So, and as I already mentioned, some kind of confidence matrix that are relevant to ensure our trust in the black box behavior later on. The next point is the change over time. So I've talked about the drift, and NXG, for example, talks about what do we have later on in series and so on to do on monitoring, for example, that we see drift monitoring or drift detection. And if there's a drift detection, of course, we have to update the system, to retrain the system, maybe whatever. Then the additional evidence, of course, we've heard about the AI safety assurance case. So the assurance case in general describes all of the evidences that are necessary, and we will see something in the assurance argumentation about this later on too. And then, of course, the data-driven hazards, again, clause 8.4. And here too, we're about statistical reasoning for input space coverage. So in our argumentation, there should be, of course, one part of why is the data we are using okay? Why are no hazards derived from the data or coming from the data? That's a relevant point too later on. I told you we will see a very short part how to do the assurance argumentation, and that's described more in detail in the ISO PAS. But due to the restricted or limited time today, we can just have a quick look at it. So in general, what are we doing here? We have a claim. So we claim our system is safe. So that's the first step. Of course, we can break this down in, let's call it subclaims. Our system is safe is the top. Then we can say, oh, our system is safe because the sensor delivers the concrete data, and our model is trained with enough data, and so on. So we can break this claim down. And if you want to have more information to this, that's part of the clause 8 I already told you. So the claim is the statement about what does it do. Then we have the argument and the evidence. To prove that the claim is true, that our system is really safe, of course, we need some evidences. And the argument is, let's say the link between the claim, our system is safe, and the evidences. So the argument is the documentation that the claim is true by the evidences later on. And if you want to see more of those information, how that's described in the ISO PAS, that's the following chapters, clause 8 normally, and of course for the evidences too. And for the evidences, we will see some more information now. So what could be core deliverables to prove that the claim, the system is safe? And again, it's not the full list of evidences, it's just a few one. What could be a core deliverables that the claim is true? So in general, of course, we need an AI safety plan. AI safety plan, in my opinion, should be integrated, of course, in the system safety plan we have, or in the project safety plan. So I think we don't have to have a single document for this because it's the same scope, but just for the AI components, AI items, for example. Then, of course, the AI safety case summary. And this would be kind of document what we've seen on the slide before. That's the argumentation with the collection of all of the evidences that the claim our system is safe, or our system is safe in all environments, or whatever. That this is true. So that's our argumentation here, the AI safety case summary. Then, of course, as we've talked about, we need some evidences about our data. Then we need kind of data lifecycle report. I would say, as I said, the data governance lead, or however you call him, is kind of config manager. So you could see this as kind of parallel, in my opinion, that's my personal opinion, to kind of configuration management report. So, of course, it covers the collection of data, the labeling of data, the quality control of data, the maintenance of data. So I think there are some parallels, not everything, but some parallels. Then, for example, you need, of course, the model that is used, the model definition, the training report. So that's part of architecture. So what model do we need or do we deploy later on? How do we train it? With which data did we train it? And so on. Then, of course, kind of model evaluation and robustness report. We've talked about verification, of course, validation, and so on. So let's call it kind of in the classical world test report or verification report. So that's kind of this direction. And a last example, for I told you we need some kind of monitoring after deployment. So there could be kind of monitoring and drift management plan. How do I want to do this later on? So this could be some of the deliverables, and of course there would be more in a real project, but that's just some examples. So just a few words to what could you do now? How could you start with this? And first point, of course, would be start with challenge your process world. So in the first step, of course, you have your process world, maybe without the machine learning, but as we're talking, for example, about state-of-the-art processes, then you could take Automotive SPICE 4.0. You got one of the supporting processes, the machine learning data management. and the engineering processes, the machine learning engineering process group with requirements analysis, architecture training, and model testing. I won't go into this in detail, but if you want some additional information, just give me a second. Then Jürgen already told you there's this Automotive SPICE 4.0, and here is the, for example, machine learning engineering process group, where you can see those little red signs that Jürgen explained at the beginning. And if you go into one of those base practices, for example, then you see there are some so-called knowledge nuggets, and the knowledge nuggets are there for additional information. So there you can find additional information where you can go into the into the SPICE for cars. If you later on get the presentation, there will be a link here, or as Jürgen told you at the beginning, it's just spiceforcars.com if you're interested in. Yeah, then one more slide to what could you do at the beginning, and it's very, I know it's very high level, but we don't have the time to go into detail. Of course, one of the first steps should be define and apply the new roles. If you got the new roles like safety manager, data governance lead, and so on, or if you have the definition, then just align it with the actual roles that there are. An AI safety manager doesn't necessarily be a new role. You can integrate it in an actual role that is already existing, for example. And as soon as the roles are defined and applied, then you can start creating the first work products, starting with, of course, the AI safety plan, maybe aligned with the classical safety plan or integrated in it, then kind of data lifecycle template, so kind of maybe derived from other possible documents that you have, like work products, so the data lifecycle can be kind of similar. And of course, then just as example, for after SOP kind of monitoring model and drift plan, and integrate, of course, all of the other information that you have in the relevant plans. For example, if you have tests, then integrate it in the test plan later on. So just as a small example how to start, but nothing in detail. Yeah, so just a few takeaways for you. So what we've talked about is the ISO PAS 8800 bridges the gap between AI innovation and functional safety. Then, as we've told, it complements the ISO 26262 with its own life cycle. And of course, success depends highly on data governance, then traceability, explainability, of course, and not just the model. The model is a part of it, but not only for this. And if you go through the steps for the organization, I think that was on the last 2 slides, so we don't have to go into this. And then I would thank you for the attention. And now we're open for some questions in the next minutes, if there are some.
Yeah, thank you, Sebastian, for your great presentation. So just a reminder for the other participants and listeners, please use the question and answer section to ask your questions. And while you are maybe thinking about what to ask, Sebastian, I have already 2 questions for you. Maybe I can start before I go for the other questions which are coming up soon. So you just recently were talking about these roles, and typically in quality models often tell us what to do, right? So they are telling us some kind of requirements, and those roles you mentioned, are those really defined inside the PAS 8800, or was it just a proposal from your side how it could be defined? So how detailed is this PAS actually going into how we should do something?
Yeah, ISO PAS 8800 defines the activities. So it was a proposal how the roles could look like from my side. But of course, it's possible to change this in projects, to change this in descriptions, because it's about the activities that are necessary, but not directly about the role itself.
Okay, good, understood. And the second question is maybe a little bit more difficult and tricky. Actually, I have a little hard time about really fully getting this and understanding this. So in the beginning, you were talking about non-determinism, right? And that there are some likelihoods, right, about the outcomes of such application of artificial intelligence. What does this mean actually for the safety? So I understood on one of your slides that you were talking about that this kind of argument that the AI system is safe is not related to a likelihood. It's yes or no, or true and false decision, right? But if the input is somehow dealing with likelihoods, how can this be the case? Or how is this actually really done? You got my point?
Did I tell that it's a yes or no? I told you it's not about yes and no. It's not black and white. It's about a kind of gray, and it's about kind of trust. So at the end, we need to build up some trust in the system by evidences, and it's about the argumentation in this kind. I think in AI systems, it's hard to achieve a real 100% coverage. So we have to have an argumentation later on why the maybe 99.9% is enough and the 0.1% is not safety relevant or does not have an influence on safety criticality. So if I told you that it's black and white or it's yes and no, then maybe I have missed something. Then maybe it's my fault. But in general, it's not possible to say 100% yes or no. It's about a kind of confidence score is possible, and you have to trust the system later on with kind of confidence score. And of course, you can have some evidences that you trust the system by maybe defining the confidence score or getting a confidence score and testing if that's real. So if I have a confidence in the system that it says, okay, it's 90% correct, then of course I can test this. I can test if in 90 of 100 environments or input data sets, my system will have the correct output. So that's kind of evidence chain later on to trust the system and to trust the development.
Okay, got it. So maybe it was my misunderstanding. But who is setting up these confidence levels? Is this proposed by the standard, or who is doing this?
To be honest, that should be part of the safety case. So by a development organization and by a kind of a risk assessment that should be part there. So like in the ISO 26262, you do a hazard analysis and risk assessment, and here it should be, of course, the same. And then you can say what is acceptable, an acceptable risk, for example.
Okay, good, thank you. Any other questions from the other ones? So please ask your questions.
Yes, I've just added 2 questions to the chat.
Oh, okay.
Right. I can also.
Now I see it. Yeah, now I see it. Okay, sorry, I had to scroll down a bit. Okay, thank you. So the very first question is, can the ISO 8800 standard also be applied of a software library only, which is integrated by someone to build up the whole solution? So the library lives in an application and provides machine learning algorithms, but the library itself do not know in which scenarios it will be actually used for in detail. Is there also an out of context approach on how to do a scenario analysis for this?
Okay, that sounds kind of complex. So did I understand it correct? The library itself is not machine learning relevant. It's used by a machine learning algorithm.
No, it's the other way around. So the library using machine learning algorithms, which is just provided for certain cases and used in an application, but finally, from a pure library provider point of view, it's not really clear how the surrounding of the car, for what it will be actually used, and so on. That's why I'm asking for is a kind of out of context approach as well, just to limit it. To say the library can guarantee that, but if you use something maybe on top, you need to do an analysis on top of that scenarios.
Okay. In general, I would say the approach is similar to the ISO 26262. So if we have a claim that we can use here for the out of context approach, then it's possible. But I'm not sure if this can be applied in your system. To be honest, that's a tricky question.
Okay.
Yeah, and there's another question as well from Christian, actually. How is an hazard analysis expected to be done to finally make the claim for safety? It's just brainstorming about scenarios and train for them. How to claim that the analysis is good enough? Any recommendations or ideas? I think this goes a bit into a similar direction of my question, which I originally raised about the confidence levels and so on.
Yeah, in general, we're talking about not a, let's say, standalone norm. You always have to take the ISO 26262 into consideration too. So the approach for the hazard analysis and risk assessment in general is the same as for the ISO 26262. But of course, the scope is kind of different for the, or not kind of different, is kind of special for the AI system here. But in general, how to go through the ISO is the same. You are just looking on the topics that are hazards or risks that are derived from the AI mechanisms. As I told in one of the slides, for example, you're talking about the data as one of the risks. And then you look what could happen if I have not a sufficient databases, for example. But the approach for the HARA itself is the same.
Okay, and then we have another question. First of all, thanks, Sebastian. Good overview. So that's the first feedback. And then it's basically about comparing the ISO PAS with the ASPICE MLE process, respectively sub 11. Do you see aspects in the ISO which are not addressed in ASPICE, but they should be added from your point of view to SPICE?
That's a good question. To be honest, I didn't do this comparison in this level of detail. I would have to go through the details. But in general, the Automotive SPICE, of course, is a process framework. And the ISO is a normative standard that describes some technical points there. So I think there will be some additional points, but at the moment I can't point them out.
Okay, good, thank you. So I was not looking into the PAS right now. So, but my feeling, and please correct me if I'm wrong, Sebastian. My feeling is a bit that the PAS is, of course, going into much more details and gives us several hints about which kind of methods can be used to implement something, right? While the A-SPICE is here a little bit more generic, right? For on a higher level, right? That's for sure one impression.
Yeah, of course, you didn't see this in the presentation here, but if you know the tables with methods, for example, from the ISO 26262, there are also some tables in the ISO PAS 8800 for, as you mentioned, which method should be applied and so on.
Okay, thank you. Any other questions? Because this was actually the last one from the Q&A list. If not, then I would like to thank you, first of all, to all of the participants of the webinar for joining us. And on the other side, Sebastian, of course, for this presentation and the discussion. And as I was telling you already in the beginning, we will upload the presentation as well, the video, most likely by end of this week. Okay, thank you and bye-bye.
Thank you, bye-bye.
Thank you, Sebastian. Bye-bye.
You are the pioneers. With your visions, your ideas, and your passion to make things better. And we are the ones who protect you from pitfalls. We are by your side whenever needed as a true fellow. Reliable, pragmatic, realistic. Together we make your product come alive. Imagine you enjoy improvement. Process Fellows.